Pythagorean trigonometric identity comes directly from the unit circle, which is simply a circle with a radius of 1. Any point on this circle is exactly 1 unit away from the center. This line is also the hypotenuse of a right-angled triangle formed within the circle. Using basic trigonometry, we can find the lengths of the other two sides of this triangle. To find the length of the adjacent side, we use cosine theta. Cosine theta equals the adjacent side divided by the hypotenuse. Since our hypotenuse is 1, the adjacent side is just cosine theta. Similarly, to find the opposite side, we use sine theta. Sine theta equals the opposite side divided by the hypotenuse. With a hypotenuse of 1, the opposite side becomes sine theta. Now, because this is a right-angled triangle, the sides must follow Pythagoras' theorem. If we substitute the lengths we found, we get cosine theta squared plus sine theta squared equals 1 squared. This simplifies neatly into the fundamental Pythagorean trigonometric identity. At this point, we should be very familiar with the Pythagorean identity. But what other identities can we create from this? If we take the original Pythagorean identity, sine squared theta plus cosine squared theta equals 1, and divide each term by sine squared theta, we get the following. The first term, sine squared theta divided by sine squared theta, simplifies to 1, because anything divided by itself equals 1. The second term, cosine squared theta divided by sine squared theta, simplifies to cotangent squared theta. And the final term, 1 divided by sine squared theta, becomes cosecant squared theta. Therefore, we have created a new identity. 1 plus cotangent squared theta equals cosecant squared theta. In a similar manner, if we return again to our original Pythagorean identity, sine squared theta plus cosine squared theta equals 1, and this time divide each term by cosine squared theta, we find another identity. The first term, sine squared theta divided by cosine squared theta, is tangent squared theta. The second term, cosine squared theta divided by cosine squared theta, is simply 1. And finally, 1 divided by cosine squared theta equals secant squared theta. Thus, we have derived another useful identity. Tangent squared theta plus 1 equals secant squared theta. These three forms of the Pythagorean identity are useful in various parts of mathematics, especially when tackling advanced topics, such as integration, in A-level mathematics.